All right, so what I want you to do with this stuff is I really want for you to know how graphs look like and what they're shaped like and all of that kind of stuff. A linear function, y equals mx plus b, we've beaten that horse to death. It's basically a straight line, and it kind of starts on one side and goes up like that. Or it could go down. Now, think of this m, that's the slope, right? And then this is x to the 1 power. So we call this, the degree of this polynomial is to the first power. Degree 1. All right. And then what I want to notice is that the endpoints for this thing is it starts on one side going down, and it ends on the other side going up. Now, there's another formula. This is the y equals ax squared plus bx plus c. This is a quadratic equation. The degree of this quadratic equation, actually, yeah, here, I'll just write it here. Degree is 2. It's an even degree. And if it's an even degree, what happens is the polynomial will kind of graph like this, depending, of course, what a, b, and c are. Now, if a is positive, it's going to be a happy face parabola. If a is negative, it's going to be a sad face parabola. Pause. Erica, you're saying you're having trouble seeing. Is anybody else having trouble seeing? Let me see if I can focus that in a little bit. All right. Erica, what you might want to do is you might want to move or change the size of that little window that you have to be bigger. I really don't know how to help you once I do that. It's all gray. You might have to jump out and jump back in. I'm sorry. All right. Because no one else is having trouble, right? All right, so we've got a even polynomial of degree, well, what I mean by even polynomial is it's an even degree polynomial because it's an x squared term. And notice how it starts up and it ends up. It starts and ends in the same direction. Now, the coefficient, the leading coefficient, that's this number over here, with the linear term, it would be that number in front. If that thing's positive, we know that it's going to start up, end up. It's going to be a happy face parabola. If it's negative, like a -4 or something like that, it's going to be a sad face parabola, or it's going to start down, end down. Does that make sense? All right. There's another form that you can write this in. This is called standard form. Another form that people like is a times x minus h squared plus k. That's just writing it a little bit differently. In order to go from this form to this form, you have to use this trick called completing the square, which actually is really an important trick to learn. If you learn how to complete the square, you'll be able to get it from here to this form to this form. But this form right here is called vertex form of a parabola, and it's really nice because the vertex form of the parabola tells you exactly where that vertex is. I think I kind of went over this with you. Remember, this thing moves it up and down, and this thing moves it right and left. This, again, is the same as that A. It kind of tells you how that parabola opens up or opens down, or is it fat or skinny, and all of that kind of stuff. Do you guys remember that? Let me know. Tell me yes or no, all of that kind of stuff. All right. There's another parabola that we have, or actually it's not a parabola, it's a polynomial. It's y equals, I don't know, x cubed. That's the parent function. But really what you could have is you could have ax cubed plus bx squared plus cx plus d. And it's basically you can have the cubic term plus all of the other terms below it. And that would give you a cubic function that kind of looks like this. If it were exactly y equals x cubed, that graph would kind of look like this. So it would move the vertex, or I guess there's no vertex to this thing, but it would move the center of this thing to this middle point right here, and then it would kind of even out these extra bumps. If you mess with these numbers, you'll get a little bit more amplified version of that bump. But to be honest with you, with this chapter, I don't even really care what it looks like in the middle. What I'm really most curious about is how is it going to look in the end? What is the end behavior of this graph? Now the end behavior of this graph, no matter how it looks in the middle, it's going to have the same end behavior no matter what you do to these numbers, A, or B, C, and D. If A is positive, this thing is going to start down, and then you kind of go up, and you know it's probably going to bend like that, and then at the end it's going to end upwards. Notice how the degree of this thing is the third power. It's an odd number. I'm kind of seeing a pattern here. If the degree is an odd number, then the start point and end points are going to end in opposite directions. If the degree is an even power, then the start point and end point is going to kind of have the same direction. Does that make sense? All right. Now, if I have something like a y equals x to the fifth power, and I could have a bunch of terms like ax to the fifth plus bx4 plus dot dot dot, you know, cx cubed plus dx squared plus ex whatever plus whatever. So it's a, b, c, d, e, f, you know, plus f all the way out here. And a, b, c, d, and f, those are all just numbers. That would look something like this, but it would have like maybe 3 bumps inside or 4 bumps inside. You know what I mean? But again, if it's an x to the fifth power, the degree of that is to the odd power. That means I know it's going to start and end in opposite directions. I really don't care, in this chapter at least, what that middle part looks like. I just want to know if you understand the end behavior of it, and it's going to kind of have the same end behavior as the degree to this third power. Now I can change that end behavior if I change the number in front. See, if I make this a negative slope, this line would look like this. If I make this a negative coefficient in front, this graph would look something like this. Right? It would start high, and as you go to the right, it would go down. So, if I were to give you just the degree of a polynomial, let's say degree 4, coefficient 3. Immediately when I take a look at this, I think to myself, all right, the degree of that is an even function. It's an even power. That means I'm going to have y equals x to the fourth, blah, 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 blah. And the coefficient is 3. It's a positive number. I know that an even power will start and end in the same direction. I know that the coefficient being 3, a positive number, means I'm going to kind of have a happy face shape. It's going to start up and it's going to end up. And I'll tell you what it probably ends up doing is it probably ends up going like this, like that. But then again, I don't care about what the middle part looks like. I only care about how it ends and how it starts. If this number were negative, then the graph I would choose is probably this thing upside down. I think with those tools, you guys should be able to hit this homework pretty hard. Let me do